Hey everyone, today we are going to talk about heat of fusion and heat of vaporization, two new equations for you. We'll start by reviewing the heating curve of water. So remember at below 0 Celsius, we've got water as a solid particle. Once we get to 0, the melting point of water, or freezing point, as we're moving from left to right, it'll melt into a liquid. So the flat lines are the phase changes. And then from 0 to 100, we have liquid water heating up here. So all these slanted lines are heating up. And remember that liquids have a little more energy. And then we get to 100 degrees Celsius, where water will boil. Again, we're moving from left to right here, into a gas. And gases have the highest energy. And water would exist as water vapor at over 100 degrees. So if you're going the opposite way, right, water would condense at 100 Celsius as well if it cools down, and it's also going to freeze at 0 Celsius if you're cooling it down. All right, the heat of fusion. So this applies to melting and freezing, and it's how much energy you need to change 1 gram of a substance from solid to liquid or liquid to solid. Okay, the heat of fusion for water is 334 joules per gram, where the heat energy here is going to be Q. So Q is heat energy. We're going to use Q to represent energy. And we've got this formula, Q equals mass times delta HF. Okay, pretty straightforward equation. And delta HF will always be this number, 334 joules per gram. Remember, this only applies to melting and freezing. Let's take a look at what a practice problem of this might look like. How much energy is needed to melt 500 grams of ice? So we're just going to plug in these numbers to our equation. 500 grams times delta HF, 334 joules per gram. And we get 167,000 joules of energy. So we're going to use the letter J to represent energy, and that's joules of energy. Okay? Again, we want to use this number for melting and freezing, 334. But what if we have evaporation or condensation? Then we're going to look at the heat of vaporization, which is how much energy we need to evaporate or condense 1 gram of water or liquid. We're going to look at the heat of vaporization for water, which is 2,260 joules per gram. So just notice that this requires a lot more energy. And if you've ever had to make pasta or boil an egg, you'll know that it takes quite a lot of energy to evaporate water. Okay? So the equation is very similar. Q equals m delta H V instead of F. And we're going to use this number every time we talk about boiling or condensation. So let's take a look at what an example of this kind of problem would look like. How much heat or energy is needed to boil 500 grams of water? So m is our mass in grams. Delta HV, we're just going to plug in this number. And we get this big ol' number. If you want, you can turn this into scientific notation. 1, 2, 3, 4, 5, 6. Okay, both of those are acceptable answers here. Remember, the units for energy are going to be in joules. Okay, we want joules for energy. All right, and again, we're using this bigger number, 2260, whenever we're dealing with boiling or condensation or evaporation. Okay, so if you see those words in the problem, you want to make sure you use the bigger number here, 2,260. Okay. This third problem, what mass of steam is required to release 4.97 times 10 to the 5th kilojoules of heat energy on condensation. Okay, so a couple of things here. We're given kilojoules, 4.97 times 10 to the 5th kilojoules. We're going to want to convert that to joules. So how do we do that? We're just going to multiply by 1,000. Okay, and so that'll give us 4.97 times 10 to the 8th joules. Remember, we want joules because both of our constants here are in joules. Now, I have to figure out which equation I'm going to use here. Which constant am I going to use? And so we see the word condensation. So for condensation, I'm going to use these numbers here. So here, Q equals m times delta HV. We're solving for mass. We don't know what the mass is, so this is different as well. So let's put it all together now. We've got enough information to plug in numbers. We don't know mass, but we do know all the other numbers. Okay, so now we just want to solve for mass. Divide by 2260 joules per gram. These will cancel out, and I'm left with about 290. Okay, so that's my answer in joules. I would recommend converting that to scientific notation. So remember, we're just moving the decimal here 1, 2, 3, 4, 5 spots. And we'll kind of round it up here to 2.2. 2.20 times 10 to the 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I moved it 5 spots to the left. So that's a lot of grams. Okay, it's a large amount of water, and we're dealing with a large amount of energy, so that makes sense. All right, so in summary, we want to use delta HF if we're dealing with freezing and melting, and we want to use delta HV if we're dealing with evaporation or condensation. If you're given kilojoules, make sure you convert to joules by multiplying by 1,000, and know that it takes a lot more energy to evaporate water compared to melting or freezing it.